Welcome to Pomodoro Joe for Thursday, August 3rd, 2023. Today we're doing LeetCode problem 17, letter combinations of a phone number. This is a medium problem. Given a string containing digits from 2 through 9 inclusive, return all possible letter combinations that the number could represent. Return the answer in any order. A mapping of digits to letters, just like on the telephone buttons, is given below. Note that 1 does not map to any letters. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. 1 and 0 don't map to any letters, but 2 is A, B, C. 3 is D, E, F. 4, G, H, I. 5, 6, 7. Looks like 7's got 4 letters, P, Q, R, S. And 9 has 4 letters. All right. So it does say it just has digits from 2 to 9, so it looks like we can ignore 1 and 0. That's nice. All right. Okay, so my approach to this will be a recursive solution. Essentially, we'll have some input number. In this case, it's 2, 3. This is a string, but it's a string of numbers. So we have 2, 3. Let's look at number 2 first. So we'll grab number 2 out of the string. It looks like 2 maps to A, B, and C. So our permutations can start with A, or B, or C. So let's just start with A. So we'll have A as the first letter, and then the second letter, well, we have to look at the next number. So it's 3, the next number is 3, and that could be D, E, or F. So we could start with A, and then we can have a D after that, or we can have A, E, or we can have A, F. Let's see what they do here. A, D, A, E, A, F, yep. Then we go to B. We've used up all the A and other letter combinations. So now we can start with B. So we have B, D, B, E, B, F. Let's see if that's right. Yep. And then we're out of A and B letter combinations, so we can start with C. And we can do C, D, C, E, C, F. And that's it. So we'll do the same thing. We'll basically grab one number out of our input, look at every letter. That letter could be the start of our permutation. So we'll grab A first, and then we can recurse. So once we grab A out of our first letter, we can take the rest of our input numbers and recurse on that. We can just say, give me all the combinations for these remaining numbers. When we get that back, we just append A to the front, and we have our unique combinations. All right, so let's put 25 minutes on the Pomodoro timer, and we will get started. So the first thing I want to do here, it looks like we need some mapping of number to character. So let's create our mapping. So I'll just call it a digit to letter map. All right, and for this, to make it easier on ourselves, let's just make a dictionary. So the input or the key will be our letter, our input digit here, and then our output will be a string of the letters or the characters that it can represent. So it looks like we don't have any zeros or ones. It says it's 2 to 9, so we can just have 2. And now I can make this a string. So the key will be the string character of the number, because that's what we're getting as our input. And the value will be just a string that represents the letters mapped to this number. So that's A, B, and C here. A, B, C. So in Python, I can actually go through and index a string. Not every language will let you do this, but in Python I can. So if I take this ABC and I do index 0, I'm just going to get A. If I do index 1, I'll get B, and if I do index 2, I'll get C. All right, so let's fill all of this in. So we have 3. I think for now I'm just going to do some empty lists here, or empty strings, and I'm just going to do the keys first, and then I'll go back and fill in the values. All right. This might take me some time, so I'm going to fast forward a little bit through this. All right, so now we have our mapping. Now we can use this mapping in our recursive function. So let's create our recursive function now. Okay, so what do we take in for our recursive function? Well, we'll take in what's left of our digits, so the remaining digits. All right, now This is a recursive function, so we need some base cases. What's our base case? Or our first base case, if we don't have any digits, then we'll return an empty list. So if not remaining digits, actually, just to be safe, let's do it as a string comparison. If remaining digits is the empty string, no more digits, then we will return. And what do we return? We return an empty list because we need to return a list of all the different combinations. So we'll return an empty list. All right, the next one, what if there's just one character left? So let's do that. So if there's only one character left, then we'll just go through each letter in that character. Or I should say, if there's only one digit left, then we'll go through every character that that digit maps to and just return that as a separate entry in our return value. So our result will equal an empty list. And then for every character in, and we'll check our mapping here. So we'll map to this digit. Well, let me grab remaining digits. Let me just break this out, make this really clear. So there's only one digit left. So that digit is the remaining digits at index 0. All right, now that we have our digit, we can get our mapping. So I can get the characters. So the characters for this digit are just in the map for this digit. So we'll look at the digit to letter map for this digit, and we get all the characters out. Maybe I'll call it letters. All right. So then for every character in our letters array, so for example, if I had 3, I would grab 3 out of this. This is a string, remember? So this is a string that just has 3 in it. I'll grab 3 from that string, that's my digit. Then I'll look it up in our map here. So 3 maps to D, E, F. Then for every letter in D, E, F, so this will be D and then E and then F, we'll just put that letter in our result as a string. So we'll just append this character. And then at the end, we return our result. All right, so this handles our 2 base cases, if we don't have any characters left, or if we only have 1 character left. Now we go on to the main cases. These are our recursive cases. So in case we have more than 1 character left, we'll still grab the first digit. So actually I can copy some of this here. All right, so for our recursive case, we still have some input. We have more than 1 digit left. We're just gonna grab that first digit out of our remaining digits, and we'll grab the letters that that digit represents from our mapping. So now we have all these letters. We still need our result. At the end, we'll return our result. So now we'll just go through all of our letters one at a time, just as we did here. For each letter, that will be the start of our permutation, and then we can call a recursive call on the remaining digits. So we'll have to remove this digit from our remaining digits, but that's pretty straightforward here. So for every character in our letters, we're going to make this character the start. So I'll call it the prefix. That's just going to be our character. So the prefix is going to be the left side of our string, and the suffix, or all the suffixes, those are going to be the right side of our string. So for this, we'll just do a recursive call on the remaining digits. So we'll call this letter combinations recurse. But now we have to pass in everything except the digit that we just popped out of our remaining digits. So we didn't actually pop this. I'm not changing this string. I guess I could. Actually, that's a good point. I could change this string. We could pop this. Well, maybe that's an optimization we'll get to later. All right. So what do I pass in for the recursive call? Well, I'm using this digit, so I can't use that digit again. I pass in the remaining digits, and we just go from 1 to the end. So essentially, this is eliminating that first digit, the digit at index 0, and we'll just go from digit 1 to the end of our string. And that gives us all of our remaining suffixes. Then we'll have to take all of those values, all these permutations that we get back. We'll go through and add our prefix to the front, and that becomes one of our results. So for every suffix in suffixes, this option will be our prefix. plus the suffix. So that will just append the prefix to the front of the suffix. And then our result, we can just append this option. All right, so we go through, find all of the permutations from this letter forward, or this digit forward, add our current prefix to the front, and then add that to our result. All right, and to kick everything off at the beginning, we have to just call return, and we'll do this recursive call on the entire string. So we'll just pass in our, what do they call it? Digits. We'll just pass in our digits here. All right, let's try this. Letters, plural. All right, try that one more time. Did I do that up here too? Nope, I was okay. I'll try that again. Typos. Okay, so this works. Let's submit this and see how we do. And we pass. And let's see, we do all right. We beat 81% for runtime and 86% for memory, so that's not bad. Now let's jump back and make a few optimizations. So one thing we could do, this is just a string, which means that we can use caching here. So let's go ahead and add cache. So this is a function decorator. What this will do is anytime it sees the same input, so I should say the first time it sees a unique input, it will run the program and cache the return value. The next time it sees that same input, it will just return the cached value. So this should save us some time. Let's try that. Actually, that did not give us a boost. That gave us a hit. Oh man, that actually, we take a hit. We go from an 81% to a 68%. That's surprising. All right, let's remove that cache. Let's not do that. Okay, so there are a couple things we can do here. So let's just clean up the code a little bit. Like this prefix, we're only using it one place and it's just assigned here to C. So we can just use C directly instead of prefix. So let's get rid of that. Instead of prefix, we'll just say C plus the suffix. That's one quick optimization. One thing we could try, I haven't really thought about this. We could try passing back just an empty string here. Then when we get down to this loop, it should handle this case for us. Let's try it, but I'm not convinced it's going to work right. Yeah, so that doesn't work because we can't pass back the empty string on the last case. All right, it was worth a shot. Okay, what else can we do? Well, let's try this just to see if this gives us any boost. We did make one change. Let's see, 88%. That's a little bit of a boost, up from 81%. All right, last thing I want to try. So I broke this out onto separate lines to make it easy to read, but that does mean the parser has to parse multiple lines when it could just parse one. So we could try putting this all in one line. Of course, this makes it harder for us to read. I wouldn't necessarily recommend this, but it might give us a little bit of a boost in our speed. Yeah, it gives us a huge boost. Now we're up to 98% for runtime and 19% for memory. So that's a huge win. All right, I'll mention one more thing we could do. Instead of using a dictionary here, we could use a standard array. But if we use a standard array, then our key here, it's a string, it will have to be converted to an index. So this will have to be essentially turned into an integer. Now we could do that really quick. Let's do it really quick. I'll speed through this. All right. Now instead of having a dictionary, I have an array here, or a list. Now one thing to note that if we have a 1 or a 2, I should say if we have a 2, it's going to map to index 0. So we can either add two dummies in here. We can have 1 or 0 and 1, and then we wouldn't have to change any mapping, but it does take up more space. Or we could get the index based on this input digit turned into an integer and subtract 2. So either way will work. Let's do that. All right. So that means that in this case, let's grab our digit out here. That way we can reuse it for here or down here. So in this case, we'll have the remaining numbers at digit 0. So we'll take remaining digits here, but we have to turn that into an integer. And then we also have to subtract 2. Let's make it easier on ourselves. Let's not do the subtract 2. Let's just turn it into an integer, and we'll just add 2 dummies in here. So this is digit 0, digit 1. They don't map to any letters. And then this is 2, 3, 4, 5, 6, 7, 8, 9. Cool. So then our digit here is just our remaining digits at index 0, but it's turned into an integer. All right. Then I can get rid of this and this. All right. Let's try that. Still works. Let's see if we can run. And we pass, but we do far worse. Now we're only at 11% for runtime and 98% for memory. So we do much better in memory, but much worse in runtime. That's interesting. And now it's loud outside, so I think I'm gonna call it here. All right, hope you enjoyed this, hope you had fun, hope you learned something, hope you can go out and write better code.